Okay, so starting with angle 1, we're going to say that angle 1 is congruent to another angle, and then we're going to work our way all the way to 3. And there are 2 routes you can take. Who has a suggestion of one angle that I could say is congruent to angle 1? Joey? Angle 2. Now, if you don't have angle 2 on your paper, you're okay. You don't have to use 2. What would be your reason, Joey? Good. Either the vertical angles theorem, write out vertical angles theorem, or vertical angles are congruent, which is the theorem itself, what it says. Okay, so he has gone from 1 to 2. Now you want to go from 2 to something else. So what angle is congruent to 2? Marquise? 2 to 4. And that would be, those are what type of angles, Marquise? Corresponding. So you either need to write the corresponding angles postulate, or if lines parallel, corresponding angles are congruent. Okay, so now we've gone 1 to 2, 2 to 4, then we would have to go 4 to 3. Again, if you don't have this written down, don't worry, you could have done it a different way and I'll go over that. Now 4 is congruent to 3, those are also corresponding angles, right? So that would be the same reason. And then you can see that we do have 1 to 2, 2 to 4, 4 to 3, so we can link 1 directly to 3 using our transitive property. All right, now the other method, there was a shorter one. You could have done it in only 4 lines of work. Obviously, your first line still being the given. Does anyone want to tell me what they did instead of stating 1 to 2? Justin?
I did 1 to 2.
Oh.
But then I just did corresponding angles for.
Okay, that actually won't work. I agree that 2 and 3 look like they're in the same relative location, like top right. But the problem is they don't share a transversal. Like if you were to look and say, what line do they both touch? Well, this one touches P and S. This one touches Q and R. So we're actually not allowed to jump from transversal to transversal. Okay, so you had to find the link there. Did anyone go from 1 directly to 4? Yeah. Is that what you did? What type of angles were 1 and 4? Good. So you could have said that angle 1 was congruent to angle 4, and that's your alternate exterior angles theorem. And then you can go from 4 to 3, which would be your corresponding angles postulate. And then you could go directly from 1 to 3 using transitive. So there's 2 routes you could take. The more angles I put in the picture, the more numbered angles I give you, the more options you have to move different directions. Okay, but you want to make sure you're always starting with this and then moving your way through. All right, let's take questions. We'll do this one tomorrow. What questions do we have from the 3.2 day 1 worksheet? You should have had ample time to check since I just walked around forever to check them. Which ones do we want to go over from? This was when we were proving that the lines were parallel. All right, so last week we talked about section 3.2, which were the converse theorems. Today we're going to do proofs with the converse theorem. So instead of asking you to prove 2 angles are congruent, I'm going to ask you to prove 2 lines are parallel. To do that, we'll use the converse theorems. Okay? So remember our converse theorems from, I guess it would be Wednesday, are the converse of the corresponding angles postulate, which says if corresponding angles are congruent, then lines parallel. Oh yeah, can you guys pass up the answer keys? I saw Caleb doing that, thank you. We have the converse of the alternate interior and exterior angles theorem, and the converse of our same side interior angles theorem. So if you guys are someone who doesn't like writing out the if-then, you just would literally write the converse of the corresponding angles postulate, or the converse of the, you have to have the word converse. we probably want highlighters today too. Because we're not going to know both pairs of lines are parallel, we're only going to know one pair are. And so we'll want to be really careful that we use only pairs that we're allowed to. Alright, so example 1, the given statement says that A is parallel to B. So I am going to highlight A, and I'm going to highlight B. We don't know L and M are parallel, therefore you cannot use any of the special types of angles with L and M yet. We also want to copy down our given on line 1, of course. They give us 2 pieces and also tell us that angle 1 and 2 are congruent. So you probably want to mark that in your picture. Alright, so we know 1 and 2 are congruent just based on the given. You want to see if you know, is angle 1 congruent to anything or is angle 2 congruent to anything using one of our regular theorems, our if lines parallel then whatever. So do we know, is angle 1 congruent to any other angle in the picture? Be careful. Is angle 1 congruent to any other angle in the picture? Marquise?
Angle 4.
No. Maddie, is that what you're going to say? So 1 and 4 are corresponding, right? They should be congruent. However, we don't know L is parallel to M. So we can't use the theorem because we don't know L and M are parallel. Okay, so you have to be careful. These ones are harder because you're not given 2 pairs of parallel lines. So you can only go along, we have transversal 1 and we have transversal 2. Okay, basically right now. We're going to prove those are parallel because the angles will be congruent. But so 1 we cannot say is congruent to 4 right now. And that's again because we don't know these are parallel. How about 2 and 4? Are those a type we know? What type, Katie? Good. These are touching the parallel line along the same transversal. So we can say that angle 2 is congruent to angle 4. And that's our alternate interior angles theorem for our if lines parallel AIA congruent. We're allowed to use those 2 angles because we know A and B are parallel. Now the goal is going to be to still use the transitive property, and then we'll add on a converse at the end. So if 1 is congruent to 2 and 2 is congruent to 4, then 1 has to be congruent to 4, right? So we'll say that angle 1 has to be congruent to angle 4. You're not going to say because if line's parallel because again we don't know that L and M are parallel yet. We're going to use the transitive property 1 to 2, 2 to 4, therefore 1 is congruent to 4 by transitive. So last week a couple of students had asked me, will the last line of my proof always be transitive? No, not if they're asking you to prove lines are parallel. Okay. Now I'm not done with my proof. My proof is to prove L is parallel to M. And whenever you see this as your proof statement, you know that you're going to use the converse theorems and postulates as your last step. So at the very end of the proof, you're going to use the converse of the whatever theorem or postulate to justify. So we should be able to say L and M are parallel now. Because since 1 and 4 are congruent, 1 and 4 are, as Marquise had said, corresponding. We've proven they're congruent, therefore these lines have to be parallel. So we'll say if CA congruent, or since our corresponding angles are congruent, then our lines are parallel. For those of you that like to write out, you would say the converse of the corresponding angles postulate. Okay, so if your proof statement is a parallel lines, then you will need to have a converse theorem as your last statement. Okay, these will make them a little bit harder. Let's look at the next one. Different given this time. This time they tell me L is parallel to M as my given, and angle 1 is congruent to angle 2. So same as last time, but different sets of parallel lines. So I highlighted L and M. Not going to highlight A and B right now. That's what I'm going to prove are parallel. So technically right now we have two transversals again. A is acting as transversal 1 and B is acting as transversal 2. So you may want to turn your paper sideways so that the parallel lines are going horizontally. It helps a lot of students visually. So again, we're going to look and check. Do we know an angle that's congruent to 1? Or do we know an angle that's congruent to 2? Based on the pair of parallel lines we've been given. What do we think? Remember, the angles would have to touch, Brett?
Angle 2 is congruent to angle 4.
No. If I trace those, watch. Those are along one parallel line. They're not touching both parallel lines that I was given, because I don't know these are parallel yet. So Marquise?
Angle 1 is congruent to angle 4.
Yes, this time we're going to do 1 to 4. See how they touch each of the parallel lines and they're along the same transversal. So we will say that angle 1 is congruent to angle 4. And that's because since L and M are parallel, the corresponding angles have to be congruent. Now we're going to use the transitive property. Now technically, we should use the symmetric property first. But I'm not going to make you put that in your proof. If you want to, you can. Angle 1 is congruent to angle 2, therefore angle 2 is congruent to angle 1. That would be our symmetric property. It allows us to flip it around. We'd have to add a line on our paper, which you guys probably have room to do. But if 2 is congruent to 1 and 1 is congruent to 4, then we can conclude that 2 is congruent to 4 by the transitive property. So when you're doing parallel line proofs, transitive property is still used, it's just in the second to last line instead of the last line. Now we look at 2 and 4 and say what type of angles are those? Those are alternate interior angles. So since these are congruent, that means that A has to be parallel to B. And again, the proof statement has to be the last line of your proof, otherwise you're not done yet. This will be a converse theorem. So we'll say since or if the alternate interior angles are congruent, which these are alternate interiors, 2 and 4, then the lines have to be parallel. On the back we have a couple fill in the blank. So just filling in the reasons as we go through. So we'll do the first one and I'll have you guys try the second one on your own. So the first statement tells me that L is parallel to M, so let's highlight that. And they also tell me that 1 and 3 are, we have conflicting numbers here. 1 and 3, this should say 3 up here. So it's right there, it's just incorrect in the given. So 1 and 3 are supplementary. I'm not going to mark those because they're not congruent, they're just supplementary. So I'm just going to trace them just so you see them. So reason 1, easy, given. What do we think reason 2 would be? Measure of angle 1 plus measure of angle 3 equals 180. What allows me to do that?
Definition of supplementary.
Perfect. We're going from the word supplementary to the fact that they add to 180. So this is the definition of supplementary angles. Now, anytime in a proof that you're filling in the reasons and they switch and start talking about different angle pairs, like we're talking about 1 and 3, then they're talking about 1 and 4, you want to go up to the picture and look, what are 1 and 4? So let's see. 1 and 4. Notice that those are along the same transversal. They do touch each of the parallel lines. What type of angles are they, 1 and 4? Maddie? Corresponding. So we're going to say if lines parallel, corresponding angles are congruent. Or the corresponding angles postulate. Next, they change from a congruent sign to an equal sign. What allows me to do that? No?
Definition of congruent angle.
Good. Congruent angles means that they are equal in measurement. So this is the definition of congruent angles. I'm going to put a star next to step 5. Step 5 is using stuff in the previous lines to come up with it. 4 and 3 equals 180. Any guesses as to how we can say 4 plus 3 is equal to 180? We had 1 plus 3 is equal to 180. And we have 1 is equal to 4. Joey? Perfect. Since we proved 1 is equal to 4, you can get rid of the 1 and substitute the 4 in. So the substitution property. You will remember that when we did the proofs in section 3.1, we used substitution in there as well. Okay? And those substitutions will show up a lot with the supplementary. Then they go from saying 4 plus 3 equals 180 to saying that 4 is supplementary to 3. What allows me to do that, Marquise? Definition of supplementary again. From the number to the word, or from the word to the number, is the definition of that word. And lastly, we can prove A is parallel to B. Why? Again, look back at 4 and 3. What type of angles are 4 and 3? That would prove A and B are parallel. Marquise?
Supplementary angles.
Close. What type of angles are these?
Same side.
Same side interior. So we're going to say if or since the same side interior angles are supplementary, then the lines are parallel. Or, for those of you that like writing out, you could say the converse of the same side interior angles theorem. Probably just about as many letters in both of those. Unless you abbreviate. So anytime your proof statement is prove the lines are parallel, this reason is going to be a converse theorem. It's going to be the flipping of the conditions. All right, see if you guys can try proof 4 while I'm passing out your homework. And then your homework tonight is going to be a worksheet, as well as your homework will be to check your answers online in Google Classroom to the 2 worksheets from when the substitute was here. So that tomorrow you're not going to have homework except to study. I'll give an optional review, number 2. But tomorrow will just be to study. So tomorrow you want to come with questions from either of those worksheets from when the sub was here. I will tell you that some of the ones on the 3.1 review worksheet were harder or more challenging than maybe what you'll see tomorrow with the triangle and the triangles that overlap. Some of those were a little bit more challenging, but still doable.